Alright, as promised, I have some example acceleration problems for you guys. We have two of them here. We're going to work through both of them and explain the whole process here, and hopefully this will help you guys with your homework and with doing this kind of problem in the future. So the first problem, already made a mistake. Spelled Draymond Green's name wrong. Draymond, what a terrible Spartan am I. But Draymond Green makes a shot towards the rim, releasing the ball with a speed of 6.5 meters per second. The shot is blocked by LeBron James, who sends the ball back the way it came at 7.8 meters per second. If the block lasted for 200 milliseconds, what was the magnitude and direction of the acceleration experienced by the basketball? The first thing we're going to need here is a formula. This is pretty clearly an acceleration problem, given that the problem asked for the acceleration. So we can just write our formula for the average acceleration, change in velocity over change in time, or written a different way, the final velocity minus the initial velocity, all over the change in time. We are also going to need a coordinate system, because this is a vectors problem. Accelerations are vectors, velocities are vectors. Anytime you have vectors, choose a coordinate system. So we have Draymond Green, who shoots the ball toward the basket, and LeBron James, who sends the ball back the way it came. So I'm going to pick from Draymond Green towards LeBron James to be positive, which means the other way is negative. With that decision made, we need to start assigning the numbers in our problem statement to variables. So this is the physics here. Figuring out which number is which variable, getting them all in the right units. We need to do all that before we can do the math and just start plugging things in and multiplying and dividing them. First, let's do an easy one. 200 milliseconds. The problem says that the block lasted for 200 milliseconds. That and the fact that milliseconds is a unit of time should tell you that this is delta t. But millisecond should raise some red flags because that is not the SI unit of time here. So we're going to want to convert milliseconds into seconds. So milli means 10 to the negative 3. So you could put a 10 to the negative 3 seconds is 1 millisecond. Or if you prefer, 1,000 milliseconds is equal to 1 second. Either way, you'll get the same result of 0.2 seconds for our duration. The next number we need to look at is 6.5 meters per second. Oops, don't want to cover up that other one. There we go. So the problem specifically says a speed of 6.5 meters per second. That and the units meters per second should tell you that this is a velocity. The question is this the final velocity or the initial velocity? Well, the 6.5 is the speed that the shot has before the block, and the 7.8 is the speed that the shot has after the block. Because the 6.5 comes first, it is our initial velocity. Or at least, it is our initial speed. To make that a velocity, we have to consider the positive or negative or the direction of that 6.5 meters per second. Draymond Green is releasing the shot towards LeBron James and the rim. That is the direction we chose for positive, so VI here is positive. The last number we have is 7.8 meters per second. That's the speed after the block, so that's going to be our final velocity, or at least our final speed. But this sentence up here, LeBron James sending the ball back the way it came, is important. Because this ball after the block is traveling from LeBron James towards Draymond Green, which is the direction we chose for negative. So we have to put that negative on VF or our math is not going to work out. And then we have our unknown variable, our acceleration that we're trying to find. So before plugging in to an equation, it's a good idea to make sure we have enough variables that that equation can tell us something. So for that to be true, we'll need to know every variable in an equation except for one. We know the final velocity, we know the initial velocity, we know the time. We do not know the acceleration, but that's the variable we're trying to find, so it looks like we're good to go, and we can just start plugging in. So the acceleration equals v final, which is negative 7.8 meters per second. That negative is important. Minus v initial, and v initial is positive 6.5 meters per second, divided by our duration of 0.2 seconds. So when you plug this into your calculator, throw some parentheses around the numerator, but you should get an answer of 71.5 meters per second squared. And the units there, you could either just know that accelerations have SI units of meters per second squared, and since we plugged everything in SI units, we should get a value out in SI units, or you can look at the units in your math. The units in the numerator are meters per second divided by seconds, which gives us meters per second, or meters per second squared. So here is our numerical final answer, and now we need to interpret this answer. So the problem asked for the magnitude of the acceleration. Magnitude does not have any direction, it's just the number with its units. So the magnitude of the acceleration was 71.5 meters per second squared. For the direction, we need to look at our coordinate system and at the sign of the answer. So we have a negative sign on our final numerical answer here, and negative in our coordinate system was towards Draymond Green. So that tells us that our acceleration here was towards Draymond Green. We can ask ourselves, does this make sense? Well, to begin with, the ball had an initial velocity to the right, and the block slowed the ball down. So when something is slowing down, the acceleration has to be opposite the direction of the velocity, or to the left in our problem, or negative. Also, once the ball comes to rest during the block, LeBron James is then speeding it up back towards Draymond Green, which would also imply to the left, because when you're speeding up, the acceleration points the same direction as the velocity. So that's that whole problem. Now let's go over and look at the problem on the right. A dragster traveling at its top speed of 150 meters per second deploys its parachutes to slow down, experiencing an acceleration of 9.0 meters per second squared for a duration of 4.5 seconds. What is the speed of the dragster after this deceleration? Again, we'll start with an equation. Even though the acceleration was given to you and isn't the unknown, this is still an acceleration problem. We just have a different unknown now, but we can use the same equation. We're going to need to choose a coordinate system. This problem didn't tell us anything about left, right, up, or down, or anything like that, but this dragster must be traveling in some direction, and whatever direction that is, I'm going to take that to be positive. So you could pick something different, but that's what I'm just going to use for this problem. Once we have a coordinate system, we need to start assigning our numbers to variables. So again, one of these is a little easier than the rest of them. 4.5 seconds is clearly a duration because it has units of time. We also have this 150 meters per second, which is going to be one of our velocities. The question is which one? That 150 meters per second happens before the acceleration, so this must be our initial velocity of 150 meters per second. And we already decided that whatever way this dragster is traveling, we're going to call that positive, so it is positive 150 meters per second squared. This last number, 9.8 meters per second squared, has units of meters per second squared, which are the units of acceleration, and the problem even says an acceleration of, so that very clearly tells you that this 9 meters per second squared is our acceleration. But as always, we need to check for positives and negatives on any of our variables that are vectors. So time doesn't qualify, but velocity and acceleration does. And the problem says the dragster is slowing down. And as before, slowing down means the acceleration is in the opposite direction of the velocity. So since our velocity is positive, our acceleration must be negative. If our velocity were negative, that would mean our acceleration was positive. And last but not least, we have our final velocity, which we do not know, but that's what the problem asked for. And we can check our equation to make sure we have enough information to proceed. We have the acceleration, we do not have the final velocity, we have the initial velocity, and we have the time. So the only thing we don't have is the final velocity, and that's what we're trying to solve for, so we are good to go. Now we can start plugging in. So A is negative 9.0 meters per second squared, equals V final, which we do not know, so just leave it as VF for now, minus V initial, which is positive 150 meters per second, all over our duration of 4.5 seconds. Now, to solve this one algebraically, it's a good idea to just get rid of our fraction first and multiply both sides by 4.5. So on the left, we get negative 40.5. Checking the units here, meters per second squared times seconds gives us units of meters per second over there, equals VF minus this positive 150 meters per second. Now we can add 150 meters per second to both sides to get VF equals positive 109.5 meters per second. And that is our numerical final answer. Again, we want to interpret this. So the magnitude is just the number. Because our answer is a vector, it will have a magnitude and a direction. The magnitude of the velocity is the speed, which is what we were asked for. Not sure what happened there. But that is just 109.5 meters per second with no positive or negative. The direction, we weren't asked for the direction, but we may as well check to make sure we understand. For the direction, you look at the positive or negative of your answer. The math is trying to tell you the direction, you just need to learn to listen to what the math is trying to tell you. If we look at our coordinate system, negative is to the left and positive is to the right. So based on our diagram, the final velocity is to the right, or in the same direction as VI. So this dragster has not switched directions, it's kept going the same way, it just slowed down. So that's it. There are many different ways that I can frame this type of problem, but if we're using this equation that you see up at the top, the acceleration, the final velocity, the initial velocity, and the duration, I will have to give you 3 of those, or at least enough information to figure out 3 of those. Sometimes a problem might say an object accelerates from rest or slows down to a stop. So sometimes one of those variables might be 0, and the problem might tell you that in words, not in numbers. So be aware of that as well. But always Pick your coordinate system. Always make sure you have SI units for everything. Always check your positives or negatives. So there's a couple negative signs in this problem that if you don't get those right, then you're not going to get the right answer. Then work through your algebra, check your units, and make sure you know how to interpret your numerical final answer in terms of magnitude and direction. That's all for this video. Hopefully it will help you to understand the material that we covered in class last week and on the homework problems. Have a good day.